All right, let's talk about solving exponential equations. So we're going to solve the following exponential equations. So this first problem, we have 3 as our base raised to the power of 2x is equal to our base 3 raised to the power x plus 5. Some things that hopefully we notice here right away is the base over here is 3, the base on the right side of the equal sign is 3. And what we can do with that is when the bases are the same, there's a property that says we could take the exponents on each side and set those equal to each other. So only if the bases are the same, we could set the exponents equal to each other. So we're going to end up with 2x is equal to x plus 5. And then since we're solving, all we got to do is solve this for x, which hopefully at this point in time in algebra, you're pretty strong at solving this for x. So if I have x on both sides, I want to get those together by subtracting x from both sides. 2x minus x is x. And on the right side, I have 5. So this first one, I get x equals 5. So that's a very basic situation. When the bases are the same, we could take the exponents, set them equal to each other, and solve. So let's get a little bit more complex. I have 2 raised to the 2x power is equal to 16. I got a base of 2 over here raised to the 2x. On the right side of the equal sign, I have 16 raised to the first power. But the key here is I got a base of 2 on the left side and a base of 16 on the right side. That is not ideal. What we want to do is we're going to have to do some rewriting here to make sure we have the same base on both sides. Now, kind of a rule of thumb that I use, I look to try and make the same base to the smaller of the two numbers. So I have a base of 16 over here, a base of 2 on the left side. So the left side already has my base of 2, so I'm not going to change anything over there. I'm going to still leave it as 2 raised to the 2x power. The right side with the 16, we're going to have to do a little bit of work. So I want a base of 2. So I got to figure out 2 to what exponent will give me 16. So 2 to what power will give me 16. And you could use a calculator, kind of guess a check, use the tables, whatever. But what you're going to find is 2 to the 4th power will give me 16. So all I did is I rewrote this inside piece, the 16. What's going to happen is this exponent, even though it's just a 1, that's still there. And this is a good habit you want to get into for the future problems I'm about to do. So now you're going to have to apply properties of exponents. When I have exponents on the inside of parentheses and the outside, we multiply them. So I got to take 4 times 1, which is 4. So I have 2 to the 4th power on the right side. On the left side, I have 2 to the power of 2x. So I didn't really change the problem. All I did is rewrote it, because 2 to the 4th is 16. These are the exact same here. So nothing's changed. So now I have bases are the same. So if the bases are the same, we could take the exponents, 2x and 4, set them equal to each other, and now it's just down to solving like we know how we should at this point in algebra. So I divide by 2, and I now know x equals 2. One last problem I want you to show you to really get more complex on these. The final one, I have 4 raised to the power 3x equals 16 raised to the power 2x plus 3. So we're running into the same issue. I got a base of 4 over here, a base of 16 over there. Can't set the exponents equal to each other yet because this is 4, that's 16, they're not the same. So again, I'm going to start with the smaller of the two. So I'm going to keep the 4 as my base. And I'm going to see if I can rewrite 16 as a base of 4. So I still have 4 to the 3x on the left side. What I'm going to do is I'm going to try and rewrite this 16. So I'm going to put some parentheses here, and I got to figure out 4 to what power gives me 16. And what you're going to find is if you take 4 and square it, that's going to give you 16. The only thing is this 2x plus 3, that is still an exponent. So we're going to put that right there. Just like before, with the parentheses here, we're going to have to clean this up using properties of exponents. So whenever you have an exponent on the inside of parentheses and an exponent on the outside of the parentheses, you need to distribute or multiply these. So take the 2 times the 2x, that gives you 4x. 2 times a 3, and that gives you 6. So I still have 4 raised to the 3x on the left side, but on the right side I now have 4 raised to the 4x plus 6 after we distribute there. So I now have rewritten this. I haven't really changed the problem, but now I have a base of 4 on the left side, a base of 4 on the right side. So when the bases are the same, we can take the exponents and set them equal to each other. So I have 3x is equal to 4x plus 6. All we have to do is use our basic algebra skills to solve this. So I'm going to try and get our x's together. I'm going to subtract the 4x over. And what that's going to give me is 3x minus 4x is negative 1x. On the right side, I have 6. I'm going to kind of run out of room here, so I'm going to continue this over here. Negative 1x is equal to 6. Just got to keep solving this, get x by itself. So this is negative 1 times x equals 6. So I'm going to divide by negative 1, divide by negative 1, and we find that x equals negative 6. And that is solving exponential equations.